Lesson 11:3, perimeter and area, similar figures. What is the perimeter of a square that is 1 unit per side? Well, we'd go 1 plus 1 plus 1 plus 1, or 4. And the area would be 1 because it's side squared, or base times height, whichever you like. 1 times 1 is 1. What's the perimeter and area of a square that's 3 units on each side? Well, the perimeter would be 3 plus 3 plus 3 plus 3, which is, or 4 threes, which is 12. And the area would be 3 squared, or 9. What's the ratio of the perimeters? So if I take 12 and divide it by 4, I get 3 to 1. What's the ratio of the areas? Well, that'd be 9 to 1. Now wait, are 3 to 1 and 9 to 1 the same? No. But wait, what's 3 squared? 9. So maybe the ratio of the areas is the ratio of the perimeters squared. Areas of similar polygons. If two polygons are similar with the lengths in a ratio of a to b, then the areas are in the ratio of a squared to b squared. Remember, perimeters are lengths. The perimeter of triangle ABC is 16 feet, and its area is 64 square feet. The perimeter of triangle DEF is 12 feet. Given that the triangles are similar, find the ratio of the area of triangle ABC to the area of triangle DEF. Well, what do we know? We know that's a perimeter, and that's a perimeter. So we know our perimeters. So we could find the ratio of the perimeters, which are lengths. And I did the triangle ABC on top because it comes first. So their lengths would be 16 to 12, which I could have reduced. Would have been easier if we had said, oh, that becomes 4 to 3. And then the areas are the length squared. 16 squared over 12 squared is 256 to 144, which is 16 to 9. Or maybe we just said 4 squared over 3 squared would be 16 to 9. What is the area of triangle DEF? Well, we know the ratio of the areas is 16 to 9. I could actually use the area given in the problem for triangle ABC and set up a proportion. So the tops here were triangle ABC, the bottom were triangle DEF. This was the ratio from over there. So we can just cross multiply. 16a, 9 times 64, and divide both sides by 16. So the area of triangle DEF is 36 square feet. The ratio of the areas of two regular decagons is 20 to 36. What is the ratio of the corresponding side lengths? Well, we know our areas, it said areas is 20 to 36. That's the a squared to b squared. The lengths are a to b, so that means I have to take the square roots. Because notice the areas are squared, the lengths are not squared. To undo squaring, I have to take the square roots. So it'll be the square root of 20 over the square root of 36. So we need to simplify these square roots. So let's look at the 20. What times what makes 20, where something's a perfect square? I know. How about 4 and 5? And how about the 36? Oh, we already know the square root of 36. So on the top, the square root of 4 is 2. So I have 2 square root of 5. And the bottom is 6. But wait, that's not simple because we can actually reduce the 2 and the 6. If I divide them both by 2, get square root of 5 over 3. Rectangles 1 and 2 are similar. The perimeter of rectangle 1 is 66. Rectangle 2 is 35 feet by 20 feet. Show the steps you'd use to find the ratio of the areas and then find the area of rectangle 1. Well, let's see. I know the perimeter, that is a length. And I know the length and width there, so those are also lengths. So I know lengths on both of them. There's my first rectangle. There's my second rectangle. Notice there's an issue. The first rectangle is in inches. The second rectangle is in feet. So we need to change that. So we'll convert the 66 inches to feet. Just divide by 12, and you get 5.5 feet. Because there's 12 inches in 1 foot. And we can find the perimeter of rectangle 2. It'll be 35 plus 35 plus 20 plus 20, or 110 feet. So now I could find a ratio of the perimeters, which would be a ratio of the lengths. Do 5.5 over 110, or that reduces to 1 to 20. If I divide them both by 5.5, yeah. Now that I know the ratio of lengths, the ratio of the areas is the lengths squared. So I'll square the 1 to 20. So that was my length. So here's to find the areas. I square that. 1 squared over 20 squared, or 1 to 400. Now that I know the ratio of my areas, I can actually find the area of rectangle 1. The area of rectangle 2 would just be base times height, 20 by 35, which is 700 square feet. Now I can write a proportion. So this was my areas. On the top is rectangle 1. On the bottom is rectangle 2. Cross multiply, so I'll have A times 400 and 1 times 700. Divide both sides by 400, and A is 7 over 4, or 1.75 feet squared.